بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Welcome everyone. I'm very glad to present to you our research, novel bio-inspired artificial muscle using spiral winding SMA wire with application in lower limb exosuit.
This is Hussein Fuad Muhammad Ali, Associate Professor at Banha University and Professor Youngshik Kim at Hambat National University.
Motivation and inspiration. We want to build an artificial muscle based on the phenomena of shape memory alloy, where the material itself changes a crystal structure from martensite to austenite when it is heated, which causes a change in internal stresses and strain, and then forces and displacement.
Compared to traditional electrical motors, SMA-based actuators have several advantages like compact size and weight and compliance, and can be augmented in human clothes easily.
Challenges. Shape memory alloy have very limited contraction from 2% to 5%, so we need to make long wire, which cause winding stage, configurable output stage, variable output, high packing factor, hexagonal and spiral architecture. Conceptual design. Stack of spirals. We have two planes of spirals, layer 1 and layer 2. And we have the red color lines shows the transition from plane A and plane B to reach the output plane C. The output stage contains one pulley, two wires.
In this video, we show a 3D model of the spiral SMA linear actuator SSLA when it is heated and ambient cooled. We also show an enhanced version of the same actuator.
The Exosuit prototype utilizes 8 actuators. We need reference points, so we use shoulder guard and taekwondo belt for longitudinal support for the SMA actuator, and transverse belt, and also back support belt. Each hip and knee joint have bend actuation and extend actuation with the SSLA actuator. The output stage of this actuator have a connection point, flexible connection point, and each link have Bluetooth IMU module to measure the angle of the hip and knee for the right and left side.
This figure shows the control circuit where we have 8 power transistors to drive the 8 SMA actuators with up to 100 volt and 33 ampere with heat sink. Also, we have 8 thermocouples to monitor the SMA actuator's temperature. Also, there is optocouplers to isolate between the power side and the control side. We have 4 Bluetooth modules to receive the angles from the IMUs attached to the hip and knee for the right and left side of the Exosuit. Also, there is 2 Arduino duos for the right and left side. Then we send the data to the computer or Jetson Nano.
In this video, we show the serial communication between the Arduino Duo controllers of the right and left side of the Exosuit through ROS to reach the simulator.
We first run the ROS core, then we establish the serial communication in terminal 1 and 2 with the Arduino in the right and left. Then we collect the data, log data, for the right and left side in terminal 3 and 4. Terminals 5, 6, 7, 8 shows the hip and knee angles for the right and left side. And finally, Coppelia Sim simulator shows these angles, which happen in the real world.
In this graph, we show the connection between the ROS nodes, which represent the Arduino Duo controller, to reach the simulator node through ROS topic, which carry the data. This is a human gate control. The video speed is 5 times. We can see here the energization for the actuators. Add voltage 48 from the power supply and the current reach 1.6 ampere.
This figure shows the experiment of hip control, where the dotted line is the desired trajectory, blue line is the actual angle, green and red line is the control signals of the flexion and extension SMA actuators. The hip angle follow the desired trajectory. The below figure shows the temperature of the actuators.
Thank you very much for listening and looking forward to receive your useful feedback. Assalamu alaikum wa rahmatullahi wa barakatuh.